over the cubed root of 8. Move that to the bottom. Okay, cubed root of 8 is 2. So I've got 1/2 times 1 over x to the 5th. Multiply the numerators, multiply the denominators. So your final answer there is 1 over 2x to the 5th. Kind of the same deal here with number 2. You still don't have a whole lot going on in here. You're raised to a negative exponent. Okay, so let's try it the same way we did this last one. This would be 16 to the negative 3/4 power. I'm going to go ahead and write that as 1 over 16 to the positive 3/4 power. Okay? Just save myself a little bit of room. And then power to a power would be negative 8 times negative 3/4. And if you need to do a little multiplication over here in the margin, right, there's nothing wrong with that. It'd be 8 times 3 is 24 over 4. Negative times a negative is a positive. Okay, so this reduces to positive 6. So rewrite this as a radical. This would be the 4th root of 16 cubed. Okay, so I'm going to take the 4th root of 16 and then cube it instead of doing the 4th root of 16 to the 3rd power, okay, which is going to look like this. You got 4th root of 16 cubed times, and then I got my y over 6 over 1 here. 4th root of 16 is 2. 2 cubed is 8. So this is y to the 6th over 8. All right. The first thing I want to do here is get rid of my negative exponent by bringing it up here. So you're going to have x to the 1/4, y to the 3/4, and that's over 1, so we're just going to leave it like so. Okay, do I have the same base? I do not. Okay, so as far as combining exponents goes, remember what we said, to combine exponents, must have the same base, right? Well, I don't have the same base. So as exponents, I can't combine these two things. To combine the radicals, though, I've got to have the same index or denominator if I'm dealing with a fractional exponent. Right? So instead of having these written as exponents, let's write them as radicals, because the denominator is already the same, which tells me that I can combine these if they're in radical form. So let's turn them into radical form. Okay, so it would be the 4th root of x to the 1st times the 4th root of y cubed. And now I can combine these and get the 4th root of x, y cubed. So if you can't combine them one way, convert it to the other and see if there's any luck there. Okay, same deal here as far as your first step. You could either use the quotient property since you've got the same base here, or you could just bring that up to the top. Either way, you're going to end up with x to the 13th power raised to the 1/3 power. And then your properties of exponents here tell you to multiply. That's going to be x to the 13/3. Which as a radical would be the cubed root of x to the 13th power okay, so then we want to break x to the 13th down to where I can take cube roots out of it. So this is going to be the cubed root of x to the 12th times x. Okay, x to the 12th would be x to the 4th cubed. So I'm pulling out an x to the 4th with an x left inside the radical. And these last two, the first time I tried to work both of them, I ended up not necessarily getting them wrong, but just not getting them really in the correct mathematical form, so to speak. So there's certain ways that you can do these that makes it a little bit easier. And that really just kind of comes with practice more than anything. The more of them you do, the more that you're going to notice things and know that when I see this, it's best to do this, or just kind of figuring out what works best for you. Okay. So again, you don't necessarily have to do it the way that I'm doing it, but right now probably be best. All right. We've got similar to what we had in the first couple of examples, with the exception of what's what's inside the parentheses is a bit more complex than our first couple of examples. So I'm going to do just a couple of things a little differently. I'm going to distribute the 2/3 there. I'm going to distribute the 2/3 there. But I'm going to take this and I'm going to write it as a fractional or a rational exponent so that I can raise this to the 2/3 power a little bit easier. Okay, so this would be xy. I can't write it as xy to the 1/2 like so, because this only raises the y to the 1/2. So I have to put the xy in parentheses, and then I need another parentheses for my 2/3. And now that looks all complicated, but it's really not. Okay? I had to put this in parentheses so that I'm taking the square root of both, and then again another set of parentheses to raise a power to a power. Right? So here I'm going to rewrite this as the cubed root of -8 squared. I'm going to leave that alone for now. until I see what's happening over here. And then power to a power, I multiply and get 2 over 6. So this is going to be xy to the 2 over 6, which reduces to 1/3. So let's just write it, since it reduces, as 1/3. Let me get my white out. All right, so I can simplify this. Cubed root of -8 is -2. -2 squared is 4. I have the same denominator here and here, and when you see that, you'll want to keep them as they are. Okay? That's a good sign to see that we've got the same denominator on our fractional exponents. So I got 4